Good morning everyone. Today we'll see the further portions of our chapter heat transfer. As we have studied in the first part about the mechanism of heat transfer, in short way, there were three mechanisms like conduction, convection and radiations. Okay, so we will study today each and every mechanism in detail. First one is the conduction. About conduction, we have studied that heat can flow only when there is temperature gradient. That is, heat always flows from hot surface to a cold surface. Okay, the rate of conduction through solids can be studied easily because it is a sole phenomena. So what is conduction? It is the transfer of heat or the internal energy which is present inside each and every particle by microscopic collision of the particles and movement of electrons within that body or within the system. Okay. Now what is the basic law of heat transfer by conduction is, it can be written in the form of an equation, that is rate which is equal to driving force upon the resistance. We have studied that what is the driving force in heat transfer. The one and only driving force in heat transfer is the temperature gradient, which is also known as temperature difference or temperature drop across the solid surfaces. The greater the temperature drop, the greater will be the rate of heat flow. Next, the flow of heat also depend on the conductivity of the material through which the heat is flowing. Conductivity means the conductivity of that material in which the heat is to be flown. Higher will be the conductivity, the flow of heat will be greater. For example, we can say conduction of heat is faster through an iron rod as compared to the wooden log because the conductivity of iron rod is much more greater than that of wooden log. Okay. So this factor is represented by the term resistance, means the conduction of heat or the conductivity of that material in which the heat is flown is represented by the term resistance, which is being expressed by this Fourier's law. Now what is resistance here? That is equals to thickness of the surface upon proportionality constant multiplied by area of that surface. Thickness of the surface upon proportionality constant multiplied by area of the surface. Thickness can be denoted by L, proportionality constant is Km and area of the surface is capital A. This is the equation for resistance which is obtained from Fourier's law. Now what is Fourier's law? It is the conduction of heat through the metal wall. This law states that the rate of heat transfer through a material is proportional to the negative gradient of the temperature and to the area normal to the direction of heat flows. Okay. In simple words, we can say that Fourier's law is the rate of heat flow through a material or uniform material which is directly proportional to the area and temperature gradient or temperature drop, and it is inversely proportional to the length of the path of the flow. Length of path of flow is the thickness. Okay. So in next line it is written over here that what Fourier's law actually states, that is rate of heat flow. You can see it is written over here in red color. Rate of heat flow is directly proportional to the area multiplied by temperature difference, that is your delta T, upon thickness, which is represented in M. Okay. Rate of heat flow is mentioned here with small q. Again, you can see the equation, that is equation number 3. Km is the mean proportionality constant. Now understand the Fourier's law by this diagram. Okay. So Fourier's law can be applied to a metal wall through which the conduction of heat is taking place according to the diagram. Okay. Just see the diagram. Now first is the A that is written over here at the right side. A is what? Area of the wall, that is capital A, meter square will be the unit for that. Now capital L is the thickness of the wall. Then face of the wall which is maintained at uniform or definite and higher temperature, that is H, capital H equals to T1 K. T is small and K will be the temperature unit. Okay, the face of the wall HH is at higher temperature side. Okay, the other face is capital C, which is CC. Okay, which is at the lower temperature side. So what will be the direction of heat flow from the higher temperature side to the lower temperature side, that is from T1 towards T2. In between that, consider a thin section of thickness dl, okay, at an intermediate point in the wall. Now this section is parallel to the plane A. For this section, the Fourier's law will be, how we can explain the Fourier's law for that thin section, that is dl. So it will be dq by d theta equals to minus ka dt upon dl. Let me show you this. So you can see this equation for that diagram which I have shown you earlier, that for the steady state heat transfer, the equation changes from dq upon d theta equals to, what is this? dq upon d theta is the constant, okay? Now equals to minus ka dt upon dl. Q is what? Capital Q is the heat transferred, theta is the time, k is your proportionality constant, and T will be the temperature. Okay, the constant K will be the function of temperature, okay, but it is not dependent upon the length of that wall, okay, it will be independent of that length. Now in equation number 5 you can see a minus sign here. So what does this minus sign indicates? It indicates the decrease in temperature in the direction of flow. When the temperature heat is flowing through a direction towards any direction, so there will be decrease in that part where the temperature has been risen already, okay? So that minus sign indicates what? Temperature decrease in the direction of the flow. Okay, this was your Fourier's law. Now next we will study convection. Okay, convection we have already studied earlier, but in detail we will study now. What is convection? It is a process in which heat flow is achieved by mixing of warmer portion of that liquid with the cooler portion with the same material, okay? Means it is the mixing of the warmer portion of the liquid with the cooler ones. This is convection. Now there are several terminologies we should know about convection is. First one is forced convection. Now what is forced convection? It is a heat transfer convection process in which mixing of fluid may be obtained by use of any stirrer, agitator, or pumping the fluid, okay, means some mechanical means is being used, okay, to achieve that heat transfer. This is known as forced convection, where it is not taking place naturally, we are using some mechanical means. That's why it is termed as forced convection. For example, in forced convection, circulation evaporators, the evaporating liquid is forced through the tube which is under pressure. Therefore, forced convection is observed. Now second is your natural convection. In natural convection, heat transfer takes place by mixing of fluid by the current setup when the body fluid is heated. For example, pan evaporator, convection currents are set up in the evaporating liquid. Okay, remember one thing, when you are dealing with any fluids, so the flow of the fluid always creates some variations in the estimation, okay? Now in this fluid flow you have studied in the earlier parts of your pharmaceutical engineering, that they flow either in laminar way or in turbulent way, okay? So it depends on the nature of the fluid that it will flow in laminar form or in the turbulent form, okay? When the fluid is viscous, the velocity is 0 at the actual surface of the wall because the fluid is viscous. It cannot be free flowing. It means that the temperature not temperature, it means that the layer of fluid which is adjacent to wall acts as a stagnant film, because the only reason for this is the fluid is viscous. Okay, film can also be observed even in turbulent flow also. Sometimes scales are deposited on the surface of the metal wall. Okay, when steam gives up latent heat, water will condense on the surface of the vessel. It changes to vapor phase also when we are applying heat. For heat transfer in tube, heat must pass through the stagnant film by conduction. Okay students, this was all for today. We'll study our rest of part of heat transfer in next class. Thank you.